Okay, so if I go back to the physics, what I did is I considered a control volume of my fluid, and I wrote the Newton law in the three directions, x, y, and z. Okay, and when I did this, I obtained that del p by del x is minus rho ax, del p by del y is equal to minus rho ay, and along z, my equation was del p by del z equals to minus rho az minus rho az and minus rho g. So I can take into factor minus rho into factor. So I get equal to minus rho times az plus g. Okay, and here, as you can see, this term rho g is due to what? It's due to the weight. Okay, so after simplification of we know that the weight is m times g, but after simplification of the volume, I get rho g. Okay, so the condition in this equation is that z should be always vertical, because when I got this result, z was vertical and the weight was along z. So I cannot apply the following relations: dp by dx equals minus rho ax, dp by dy equals minus rho ay, and dp by dz equals minus rho az plus g if my coordinate system is doesn't have z in the vertical direction. Okay, this is why here it's wrong to take x inclined and z inclined here. It's wrong. I cannot apply any more the formulas I know from the course material. Okay, so I am forced to use this system with x and z in the vertical direction so I can apply my formula. Now, once you have, if you forgot, let's say, the formulas, if you forgot how to find the slope of the lines, it's very simple to derive them again. Okay, so if you look here in this problem, the acceleration of the tank is along the inclined line. Okay, it's along this direction, but it can be upward or downward. I don't know, so I will assume a certain direction, and from my calculation I will know if it is positive or negative. So I can assume that A is up and do the calculations. If I get a positive result for acceleration, my assumption is true. If I got a negative result, then my assumption is wrong and I should say that A is down. Okay, now how to proceed here? I will just derive for you how we get the lines of constant slope. Okay, and it's very simple. If you
دكتور
have
في تعيد قصة الأي؟
فيني أعيد قصة what? Acceleration?
Yes.
Yes. Okay. In this problem, they asked you what is the acceleration of the tank. Okay, your tank can be accelerating upward or can be decelerating. So you can have A directed upward or downward. In order to know if A is up or down, you should perform your calculation. So when you calculate A, if you have a positive result, then it is along this direction, because look, this is ax az. So this is, if I assume A upward, so ax is positive and az is positive. Okay, in my problem I will calculate A, and depending on the sign of A, I will know if it's upward or down. We will see how to gather now. Okay, so if in my problem, do I have acceleration in y? Do I have a acceleration in y here? No, because I am moving in plane xz. So I can say directly that ay here is, I can directly say that it's equal to 0. Okay, so now I can derive the equation of pressure. how to do this? You know that dp by dx is equal to minus rho a, okay? And I know that p will be function of what? My pressure is function of x and z, okay? So if I integrate dp by dx equals to minus rho ax, what do I get? I get minus rho times ax times x plus a function of z, okay? Because you know from math, if I have a function of two variables and I integrate with respect to one variable, I should add, instead of constant, I should add a function of my second variable, okay? Now, once I have this result, I can derive p with respect to z to use the second equation. Just Hadi, you want me to repeat from what? From which point do you want me to repeat, Hadi? Okay. So what I want to do now, I am trying to find the expression of pressure. Okay. In this problem, you have a motion in xz plane. So you don't have a variation in pressure in y. So P will not depend on y. It will only depend on x and z. Okay. So because it's only depending on x and z, I will write that P is a function of xz. Now, in order to find what is the expression of my pressure, I will use my equations here. First, I start by dp by dx equals to minus rho ax. If I integrate this equation with respect to x, knowing that p is function of two variables, x and z, I obtain minus rho ax times x plus the function of z. Why? Because p is function of two variables. So when I integrate with respect to x, my constant will be, it's not a real constant, it will be function of the other variable, which is z here. Okay? Now, if I want to use my second equation, dp by dz equals to minus rho a z plus g, then I can say now I will derive this expression that I found now with respect to z. So I obtain del p by del z. Okay, let us derive this equation here. This term here is a function of x. So when you derive with respect to z, it will cancel out. You only have the derivation of this function. So you write here it's dfz by dz. Okay, dfz by dz will be equal to what? You already know that dp by dz is minus rho az plus g. So this is minus rho az plus g. Okay, and now you can deduce what is fz. Okay, because if I integrate this relation, I deduce that. So fz, my function fz is simply equal to minus rho az plus g times z, because this is a constant. Okay, when I integrate, it's minus rho az plus g times z plus a constant. Now it's plus a constant because f is only function of z. Okay, so now what can I do? All I have to do is to replace back into my equation, and I come up with the following result. P function of x and z is equal to minus rho ax times x plus or minus rho times az plus g times z plus constant. Okay, so this is the equation I used last time. Now, what I am interested in this problem first, I am interested in the lines of constant slope, because I want to know from my line slope, I want to determine A. Okay, so now if I tell you what are the line of constant slope, lines of constant slope correspond to the lines of equal pressure. Okay, because look here, at this on this line level, I have the same pressure. So I will demonstrate now that curves of equal pressure are lines of a certain slope. Okay, how I will demonstrate this? This is P function of X and Z. I want lines of constant pressure or curves of constant pressure. Okay, it's not by force. It can be different than a line. It can be a parabola if I have another problem, for example, if I have rotation instead of translation. But we are only interested in this material, course material in translation. This is why we will see here that in translation, curves of constant pressure will be lines of constant slope. So I will put here, I want to find constant curved lines. So I put, it should be, P will be equal to a certain constant. Let us call it constant 1, for example. Okay. So what can I deduce? I can deduce here that Z is a linear function of X, because if I write Z function of X, what I will get? I get Z equal to, if I have constant 1 and minus constant. So if I do the difference of two constants, I will obtain a new constant. So Z is equal to constant 2 minus rho AX times X over this parameter, because I moved, okay, I moved this term to the other side and I divided by rho AZ plus G. So I will take this term to the other side. I obtain the following result. Okay, so here, what do you deduce? If I remove rho, if I cancel rho, I obtain that Z is equal to a certain constant. Okay, minus AX over AZ plus G times X. Okay, this is why you directly use the formula that you directly use is that when you have linear acceleration, the constant lines of pressure are of slope, this one, minus AX over AZ plus G. Okay, so here, since you have linear acceleration, you can directly use this result. It's true that you can directly use it, but you should understand that I should have X and Z. Z always should be vertical. I cannot take an inclined frame. If I take an inclined frame and I apply this formula, I will get wrong results. So what I can say now is that because Z is equal to minus AX over AZ plus, sorry, just guys, here you should add, yes, so AZ plus, no, it's 1, AZ plus G, okay, times X plus a constant. Okay, this is the equation of Z function of X. Then this term represents the slope of the line. This term represents the slope of the line. Okay, so this is my slope, because if I do dz by dx, what do I get? If I derive this relation, dz by dx will give me tangent of angle theta, okay, which is equal to minus ax over az plus g. Okay, so if I can find my angle theta, I can relate it, find my acceleration. Why I can find my acceleration? Can you tell me what are ax and az? I can express ax and az function of a. Why? Who can tell me? How I can express
a cosine 30 and a sine 30, the projections?
Very good. Because here my tank is moving along this line. So I can project here, if I project A on X and Z, I will get that AX is A cosine 30 and AZ is A sine 30. Okay, so I have only one unknown, which is A. So now what I want to find is to find theta. Once I found theta, I can deduce the value of A. Now let us do the analysis for theta. By definition, theta, as we said, is the slope of my line, but don't forget with respect to which frame? With respect to this frame, X in the horizontal plane and Z vertical, okay? And Z vertical. So I am interested in this angle here. This is my theta, this one, okay? This angle. Now how to find this angle? First, I will divide this angle into two parts because this is my inclined line here. Okay, this is my inclined line. And this is my horizontal line. What I know is that the angle to go from here to here is 30 degrees. Okay, so if I go from this line towards the inclined line, I have a rotation in the counterclockwise direction by an angle of 30 degrees. Okay, and if you want, it's plus 30 because it's a positive slope. This line here, this line has a positive slope in X and Z. Now, because I am interested in the angle between the horizontal and the surface of my fluid, okay, I can use that, I can find the angle between the surface and the inclined line because it's very simple to find this angle as we did in the previous problem. If you remember, in the previous problem, we just found this angle, this one, okay? Because I know that the distance from here to here is 28 minus 15, which is 13. And I know that here this distance is 100, so I can easily find this angle. Now, if I find this angle, what should I do to deduce the angle with x-axis? You should look at the direction of your angles. When you moved from the horizontal line towards the inclined line, it's plus 30. But now, this surface is doing with the inclined line a negative angle. Because look, here, your angle is, if you go, sorry, from this line, if you go from this line to this one, you are rotating in the clockwise direction. So it's a negative angle. So in total, what we did, we divided our angle into two parts. I will call this theta 1, okay? So this is theta 1 to go from the horizontal x-axis to the inclined line of on which the car is moving. And to go from the inclined line towards the surface of the fluid, I am doing an angle theta 2. Okay? I will just repeat because it's... okay. So let us do the figure in a clearer way. Okay? So you have this. You want to find the angle between this line and the horizontal. This is the final angle you want, okay? This is the final angle you desire to find. But in order to find it, what you did is you divided into two parts. First, you know that this line is doing with this line an angle of 7.41 degrees. Why 7.41? Because this angle from this line, okay, towards this point, this one, I will call it theta 2, okay? How to find theta 2? You say that sine theta 2 is equal to the distance here, this distance, okay, over this one. So it's here, it is 28 minus 15, so it's 13. 13 over 100. Okay, I get the angle theta 2. But when I go from this line, from the line that is parallel to the incline, to the surface of the fluid, I am rotating in which direction? In the clockwise. Okay, but as you can see here, the angle with respect to x-axis is counted positive, if I rotate in the counterclockwise direction. So here, since I am rotating in the clockwise direction, I will count it as a negative angle. Okay, so I will say I will consider that theta 2 is equal to
دكتور بس وين ثيتا 2 بالضبط؟
Yes, I will repeat where is theta 2. So it's minus 7.41. Theta 2 is the angle between the surface of your fluid. So I'll put it here. You have two lines. This is the surface of your fluid, okay? The angle between the surface of your fluid and the line that is parallel to this one is theta 2, okay? Why you can find easily theta 2? Because look, they gave you that you have here 15 centimeter and here 28. So what will be the length here? What will be this distance from this point to this one? This distance is 28 minus 15, which is equal to 13. So you have 13 centimeters on this side, okay? And you have on this side here, which is parallel to your inclined line, you have 100 centimeters. So theta 2 is defined as the angle from this line towards the surface of the fluid. This is theta 2, okay? Now, why I cannot use directly this angle? Because theta 2 is the angle between the surface of the fluid and the inclined line. But what I am interested in is the angle between X and the surface of the fluid. So this is why I should find what is the angle from my x-axis, and if I want to represent my x-axis, it is along this line, okay? So I can say to go from the x-axis to the surface line of the fluid, I can divide my angle into two parts. First, I find the angle from X to the inclined line, and I know it, it's equal to this one here. It's a plus 30 because I'm turning in the counterclockwise direction. So this is theta 1. So theta 1 is equal to plus 30 degrees, okay? While now, when I go from this line towards the surface of my fluid, I am doing this. I am turning in this way now. I am turning in the clockwise direction. So my angle is negative. This is why theta 2 is equal to minus 7.41. So my final angle theta, which represents the slope of this line of my fluid surface with x-axis, I can say that angle theta is equal to theta 1 plus theta 2 is equal to 30 minus 7.41 equals to 22.59 degrees. Let me see your questions. Yes, Muhammad, AX is constant, okay? I am moving in constant acceleration, and I want to find what is the value of my acceleration depending on the slope of the fluid surface, okay? Yes, guys, it should be tangent, of course, not sine. Yes, it's tangent, okay? So here for theta, because here it's opposite and here it's the adjacent side. So for theta it's tangent theta, not sine theta. Okay, so tangent theta 2 is equal to 13 over 100. Okay, and I will take the negative value of theta 2 because, as I said, I am turning from this line towards the inclined one. I am turning in the clockwise direction. Okay, any other question on this? Okay, so now I found the angle of interest and I will represent it here, the angle theta, which represents the angle between, this is my x-axis, okay, it's the horizontal x-axis, this is theta. Theta is the angle from the x-axis towards the surface of my fluid. It's equal to 22.59. So this is 22.59 degrees. Okay, now since I found my angle, I can go back to the formula and I replace. I have tangent of angle theta is equal to minus ax. Okay, but as we said, we will replace ax by a cosine 30 over az. Az is a sine 30 plus g plus 9.81. Okay, this is equal to tangent of angle theta, which is 22.59. The only unknown in this equation is a, so I can solve for a, and I will obtain a negative value for a, because as you can see here, if I do the solution and I find the value of a, I will obtain a negative result. This means what? Because I obtained a negative result in my solution, this means that a is downward, because when I did my calculation, I assumed that a is upward. So when I get my value of a, it will be negative. So now I can say that my tank is has a negative acceleration. It has an acceleration downward. Okay. Concerning Muhammad, the formula of the slope is always applicable. Yes, Muhammad, the formula of the slope is always applicable, but you should apply it in a frame where z is in the vertical direction, and you should be in the case of motion, of linear motion. Okay, so if you have any object accelerating in a linear way on a linear curve, you can apply this formula. Okay, now I just found the value of a. The next step, and because it's negative, I know that the acceleration is downward. Now I will move to the next step. They told me to find the pressure at point A. Okay, if you remember in the previous problem, we said that I will go back to the previous problem because someone asked me last time to repeat the methods of calculation of pressure. So if you remember, if we go back to this figure, we said to calculate the pressure of A here, we have several ways. The first way is we start from this point here, okay, and we move directly downward. So it's as you do typically. In typical calculation of pressures, this is what you do. You say that simply PA is equal to the pressure of air, the atmospherical pressure, plus, because we are going down 28 centimeters into the fluid, plus gamma of the fluid times 0.28, and it's done. Okay? But we said also that we have another method to calculate the pressure at point A. If I didn't start from this point, if I decided to start from here, for example, if I started to move from this point, okay, then I can move first downward, then I can move towards the left. Okay, how to find in this case the pressure at A? Let us go back to the formula. We have derived together that Pxz, okay, is equal to minus rho Ax times x minus rho Az plus G times Z and plus a constant. Okay, so we said that if we want to find the variation in pressure when moving between 2 points, what can we do? We say delta P, okay, is equal to what? If you do delta of this function, what do you get? You get minus rho times AX delta X, okay, minus rho AZ plus G times delta Y times delta Y, sorry, delta Z, okay, plus when you do delta of a constant is 0. So the second method to find variation in pressure, you can take any point, any 2 points. So if you know the pressure at this point here, and you want to deduce the pressure at A, all you have to do is to say that pressure at A minus pressure at this point is equal to minus rho AX delta X of the 2 points minus rho AZ plus G delta Z of the 2 points. So if I want to apply it in this problem between, if I want to apply it between this point and this one, between this point and A, you don't have delta X because they are at the same level. X equals 0 for both. This is why when you go downward, when you move only downward, you will only end up with this term. But in this problem, if you remember, in particular in this problem, AX was 0, AZ was 0, because you are moving only on the straight line, which is horizontal, and you have only AX. So in this problem, it's AZ is 0, which is different than the second problem, okay? So this is why for this problem, when you want to find delta pressure, you can apply it between, so I will call this point here, I will call it point 1, and this point here, I will call it point 2. If you want to find pressure of A, you can apply delta P between A and 1, or you can apply it between A and 2. If you, of course, the easiest here is to do delta P between A and 1, because if you apply it, you will get that P at A minus P at point 1 is equal to, first, you have delta X between the 2 points is 0, okay? Because X of A is equal to X of point 1, so this term will cancel out. You will only have the second term, which is minus rho times AZ is 0, so minus rho times G times delta Z, which is minus gamma delta Z. So as you know to do it in general. So in general, when you go only downward, you do PA equal to PA plus gamma times the difference. Because look here, when you put minus rho G, what is delta Z? What is delta Z? Delta Z is Z of A minus Z of point 1, okay? And Z of A minus Z of point 1 is negative. It's minus 0.28. This is why when you put minus minus, you will have the following result. So it's minus rho G times minus 0.28. So you will go back to the previous result, that it is equal to gamma times 0.28. And when you take P1 to the other side, which is PR, you will get the same formula we did in the previous step. Okay? Now, the other technique to find PA is to apply between point 2 and point A. If you apply the rule between point 2 and point A, what do you get? Get the following. You have PA.
دكتور
Yes.
بس يعني فيك ترجع في البارت هيدي PA minus P1 equal please.
Yes, I will. Okay. If you, this is your formula. Did you understand this formula? Delta P equal minus rho AX delta X.
Yes.
Okay. If you want to apply it between points 1 and A, what should you do? You write P at A, P at point A, okay? Minus P at point 1 equals to minus rho AX times what is delta X? It's X of point A minus X of point 1, okay? But as you can see in your figure, points 1 and A are has the same X. Both here have X0 if you take the origin at A. And even whatever is your origin, they have the same X. So XA minus X1 will cancel out. So this term you can drop this term. okay? Since xa equal to x1. And if I continue my equation, what do I have? I have minus rho times az plus g delta z. But here az is 0, so only I have minus rho times g. And what is delta z? Delta z is simply z of a minus z of 0.1, okay? If you look at your figure here, what is z of a?